my dear students. This video is for class 7 subject physics. We are going to learn chapter number 2 part 3. The topics covered in this part are speed, uniform motion, non-uniform motion, average speed, mass and weight. What is speed? Speed is defined as the distance traveled by the body in unit time, or you can calculate the speed by dividing the total distance traveled by the total time taken. The SI unit or the standard unit of speed is meter per second. Symbol is written like this, and the other commonly used unit is kilometer per hour, and the symbol is written like this. What is uniform motion? If a body travels equal distance in equal intervals of time, its motion is said to be in uniform motion. If, I repeat, if a body travels equal distance in equal interval of time, its motion is said to be in uniform motion. In a uniform motion, the speed of the moving body remains constant. Example is a clock. In a clock, the second arm moves in a circular path with a constant speed. Now let us see an example of uniform motion. As you can see in this given diagram, a car, it is covering 90 km. It is covering 30 km in every half an hour. From the diagram, you can see that a car is covering total 90 km. How? It is covering 30 km in every half an hour. So time taken is half an hour and the distance traveled is 30 km. Every time it is covering 30 km in half an hour. From this example, we can say that the car is moving with a constant speed of 30 divided by 0.5, that is 60 km per hour. So we can conclude here that in uniform motion that the speed of a moving body remains constant. As you can see, speed every time remains same, that is 60 km per hour. Now next is non-uniform motion. If a body travels an equal distance in equal interval of time, its motion is said to be non-uniform. For example, while riding a bicycle, if the road is clear, we can ride fast, but if the road is busy, we will ride slow. So we can say that the kind of motion which we are having on a road, it is non-uniform motion. That is, we will cover an equal distance in equal interval of time or in the unequal interval of time. As you can see here in the diagram, a car which is covering 90 km, total 90 km. As you can see, it is covering 30 km, but in different times. For example, here in the first part, it is covering 30 km by taking 1 hour. In the next part, it covers 30 km in half an hour, and in the next part, it covers 30 km in 0.25 hours. That is 1/4 of an hour. So from this diagram, you can see that it is covering equal distance in unequal intervals of time. With this example, we can very clearly understand that the speed of the car is not constant. It is continuously changing. Here it is traveling with a speed of 30 km per hour. Here it is traveling with a speed of 60 km per hour. And here it is traveling with a speed of 120 km per hour. Now when bodies move with non-uniform motion, at that time we don't specify the speed of the car. There we specify average speed. I repeat, when the bodies move with non-uniform motion, we specify their average speed. What is average speed? The average speed is calculated by finding the ratio of the total distance traveled by the body to the total time taken in the journey. That is, we have already seen that average speed is found in case of a non-uniform motion. So there we have a body which is traveling an equal distance in equal interval of time or equal distance in unequal interval of time. So to calculate average speed, the formula which we apply is total distance traveled upon total time taken. I repeat, average speed is calculated when we have non-uniform kind of motion. So we have already seen speed, uniform motion and non-uniform motion. Now we are coming to a It is represented by the symbol small m or capital M. The SI unit of mass is kilogram, which is written like this, and the smaller unit is gram, which is in symbol written like this. And the relationship between kg and gram is 1 kg is equal to 1000 grams. Mass of a body is measured by a beam balance. I hope you all know what is the beam balance. A diagram is also given here. The mass of a body is expressed by only its magnitude, that is, by the number and unit. For example, we say that the mass of a body is 5 kg. Here 5 is the number and kg is the unit. So mass of a body is expressed only by its magnitude, that is, by its number and unit. Next is what is weight. Weight of a body is the force with which earth attracts the body. It is not constant for a body, it keeps on changing from place to place. It is represented by the symbol W. The SI unit of weight is Newton and the other unit is kilogram force. And the relationship between Newton and kilogram force is 1 kgf or 1 kilogram force is equal to 10 Newton. Now, weight of a body is measured by using a spring balance. A diagram of a spring balance is given over here. The weight of a body is expressed by stating both its magnitude and direction. We have already seen that for expressing mass, we have only magnitude, but weight, we have both magnitude and direction. And since the gravitational force always attracts the body towards downwards, the direction in which the weight is always vertically downward. Weight can be calculated by the formula W is equal to mg, where m is the mass of the body and g is 10. G is equal to 10, which is taken as a constant. By now, we all know that what is weight and mass, but there are few things which is related to weight and mass which we should know. That is, number one, weight and mass are not same. Usually, when I ask any student about weight and mass, they say, "Ma'am, both are the same," but weight and mass are not same. Next, kg is the unit of mass, where kgf is the unit of weight. So when I say the weight and mass of a body is mentioned in kg, whereas weight of a body is mentioned in kgf. So when I say a body is of 5 kg, it is the mass of the body, and its unit when it is kgf, it is the weight of the body. And lastly, mass of the body cannot be zero. It will have some matter in it and it will have some mass. But weight is zero at the center of Earth and in artificial satellite. This means mass of a body can never be a zero, but yes, weight of a body can be a zero depending on the position of the body. For example, here it is given that weight will be zero at the center of the Earth and in artificial satellite, where we don't have any gravitational force acting on that body. Now we will see what will be the effect of change in place on weight and mass. The mass of a body remains constant everywhere on the surface of the earth, but weight of a body changes from place to place because it depends on the force of attraction of earth. We have already learned about mass and weight. Mass is depends on whatever is contained in that body, whereas weight depends on the force of attraction of earth on it. And so mass will remain same wherever you take it, but the weight will change depending on the location of the body. For example, the mass of the body is same on earth as well as on moon. For example, if I take a body of 5 kg on earth and on moon, the weight mass will remain same, but on the moon it is one-sixth of the weight of the body on earth's surface. I repeat, the weight of the body on moon's surface will be one-sixth of the weight of the body on earth's surface. This is because of the change in gravitational force acting on that body. So from this we can conclude that mass of a body, it will remain same wherever we take it because it does not depend on gravity weight completely depends on the gravitational force acting on that body. This is the last topic of this chapter, that is difference between weight and mass. We have already learned in detail what is mass and what is weight, and now here we are going to learn one more difference between mass and weight. First one, mass. Mass of a body is the quantity of matter contained in it, whereas weight of a body is the force with which Earth attracts the body. Next, the mass of the body is constant and does not change with change in the position of the body, whereas weight is not constant for a body, it keeps on changing from place to place. The SI unit of mass is kilogram and the smaller unit is gram. The SI unit of weight is Newton and the other unit is kilogram force. Mass is measured by a weight balance and weight is measured by a spring balance. These questions has to be written in your copy. The answer. Question number one. Distinguish between uniform and non-uniform motion, giving an example of each. We have already seen what is uniform motion and non-uniform motion. You have to write the difference between them by making two columns. First, you can write the definition of uniform motion and non-uniform motion. Secondly, you can give an example. For example, uniform motion, you can give the example of a second hand in the clock, whereas non-uniform motion example can be given of a bicycle on a busy road. Next, how do you determine the average speed of a body in non-uniform motion? To determine the average speed, we apply the formula total distance traveled upon total time taken. Next, define the term weight and state its SI unit. We have already seen in detail what is weight and mass. So you have to define weight and write the SI unit, that is Newton. Now next, how are the units of weight, that is kgs and Newton related? This also we have seen that 1 kgf is equal to 10 Newton. Next question is, state three differences between mass and weight. Right now we discussed about this, many points were there. Out of that you have to write any three differences. Next question, which quantity, mass or weight, does not change by change of weight? We have already learned this, that the mass of a body does not change by the change of weight. Last question, state which of the quantities, mass or weight, is always directly vertically downward. This also we have seen that weight is the quantity which is always vertically downwards. So everyone has to write this question answers in